Hey doctor, my name is Lee Hong Chen, and today I will present about my research with the title Reinforced Learning for Automated Trading in Stock Market. As usual, we'll start in the chapter 1, Research Introduction. So, reinforced learning is a type of the machine learning where it's to let the agent to learn to make the decision based on the real-time condition with the help of the reward system, or we can call it the reward mechanism. And here I listed some of the benefit and also the potential of the DRL in the trading for the decision-making process and also the forecasting. So the problem background of the research is the emotional bias in decision making. As we know that the human is not perfect. So the decision making made by the humans will be affected by the sentimental, which means in overconfident, overreact, threat to lose, and so on. This kind of the sentimental, he will affect the decision making in the trading, where he will lead to lose in the profit of the trading. So the aim of the study is we need to create an agent that can minimize the emotional bias in decision making. Meanwhile, you also can improve the trading strategy by using the DRL model. So here are the research mapping that I done for the research. So you can see they have a research gap, problem statement, and also the research question and research objective. Actually, they are the interlinked with each other from the left to the right. So our research have a three objective, which first is to train an agent resistant to sentimental driven bias by using the DRL model. Next is to compare the performance of the DQN, PPO, and SSC model with the strength and weakness of each of the model. And next is to develop a dashboard with visualization return from the agent trend under the different mechanism. Next is about the chapter 2, literature review. So for the Standard and Poor 500, which we can call it the SP 500, it's launched in the 1957 to track the 500 major US company on the NYSE. So you can refer here, the right-hand side here, the figure actually, this is a sample of the data set from the SP 500. So the reason why we choose the SP 500 is because the high value, the high volume of a stock market, which means the liquidness of the SP 500 is high. So that is good enough for the raw data of the model to train the model. So next is about the existing model framework, which means here have a three traditional analysis in the trading. First is the fundamental analysis, which means actually just to determine the potential of the growth or towards the company or the stock market. Next is the technical analysis, actually just to predict the future price of the stock market by using the historical data. Third is the statistical model in trading. Actually, this one just to find out the opportunity to buy in and sell out of the stock market. So by using these three traditional analysis, actually it's good enough and it's the best fit for the standard stock market, but it's not applicable for the dynamic stock market. For example, you know that all the traditional analysis is manually counted by the human. So that when we can say that when you really get the answer, might be the condition of the stock market already changed. So you need to recalculate again. So that the traditional analysis is not applicable towards the dynamic stock market. And next here are the 5 deep reinforced learning model that I found from the journal they're used for the training field. So in the table, I also have filed some of the function of a model in the training, strength of a model, limitation of a model, and the result of a paper. So based on these 5 of the model that we will choose 3 that we will use for the future research. Go about the chapter 3 research methodology. So here are the research framework overview, which I will explain about the whole flow of the research from the scratch to the end of the research. So next about the data collection. So as I mentioned in the chapter 2, SP500 it will be chosen as our raw data. So the stock market between the SP500 historical OHLC data and also the volume data will be collected from the Yahoo Finance. And the time period is about the 2016 until 2024. Next, after we collect data, then we will done some of the cleaning and premium processing of the data, which means we need to handle the missing data by interpolation in order we can maintain the continuous of the time series data. And also we need to remove all the outliers in order to prevent the model to learn from the irrelevant data. Next is about the model and problem definition. Then actually this all I mentioned about at the chapter 2. So in the goal of the model is we need to identify the best model for long-term stock market strategy. So next, here is a model selection. So this 5 of a model that is from the chapter 2. So I select 3 out of the 5 of a model based on the strength limitation and also which of the more DRL model that's suitable to my title. So after this, I choose for the DQ network DQN, proximate policy optimization PPO, and also the soft actor critique SSC. So here are the reasons why I choose these 3 DRL model. So DQN is just a combination of a Q learning and also the deep neural network to approximate the Q function. So you can see here the formula Q value here actually just to calculate the expected future reward at the given stage and also the action. So here below here is the Q value update. It actually just show how the Q value is be updated with the reward and also the next action space is and also the stage for the Q value, or we can call it is a target Q network. And the next is about the loss function. Actually, just count the MSE between the predicted and also the targeted Q value. So you can see here the diagram here is just an architecture of a DQN. So as of first, the environment, which is the stage, will become the input to feed into the Q network. So the Q network, you will by using the RMX X to select which of the Q value, which have a highest Q value, between the pay and also the stage, the actions stage and also the stack pay. Then it will store in the replay memory. And also the target queue network actually just it will help to stabilize the training by scope by copy every end of the update. And actually the work is to prevent the overfitting issue. So it's a loop so that it can improve the decision making of the agent. So next is for the SAC. Actually, it's just a combination of the actor and the critic that is to maximize the expected long-term reward and also the entropy. So you can see here the first formula here on the left side, the step value function. Actually, this one just to calculate the expectation and future reward by minimize the square root of the square root between the predict and also the actual reward. And actually, this one is the same as the Q function. So by given the stage and also the action on that particular step. And the next step Q function actually just to update the Q function with the stage and also the action mentioned for the next step. So the policy learning is actually is to the policy, it will select which of the action with the highest Q value. Then it will be the policy to let the agent to train. So you can see here is the architecture of the SAC. So as a first, the actor will take the action based on the policy. Then after this, the critic, he will evaluate the action taken with the environment, which means the reward. So here we have the TD error. TD error, which means in the temporary different error. So based on the TD error here, between the action and also the real-time condition here, then he will feed in back to the policy so that he have a minor changes in the policy. And the actor will change the decision again based on the new update policy. So here the cycle will return in order until we can achieve to improve the decision-making process, which we can achieve to get the optimized decision. Actually, the people is a policy gradient-based DRL model. It's actually is to balance the exploitation and also the exploration. So it can prevent the large policy update and also to maintain the stability in the learning. So here the first is the creeper formula. Actually just help to reduce the large update in the policy so that it can help to improve in the learning stage. And the next is the total loss function. Actually is to help for the balance the policy update, the volume function accuracy, and also the exploration. And next is about the GAE. Actually, the GAE is just help to reduce the variance and also the bias, and also it's help to increase the stability of the training. So here is architecture of the PPO. So you can see here the agent actually is interact with the environment with the multiple configuration. So each of the configuration you will provide a stage and also a reward towards the agent. And then the agent will make the decision, or we can call it the action, based on the policy that he learned. So that you can see that this cycle actually this is help to continuously help the agent to improve the decision making by the experience and also the feedback from the environment. So next we will do about the data normalization and also the splitting. So the data splitting will split to the 80% training and also the 20% is for the testing. So next, this is the model training loop that we will done for the DQN, SAC, and also the PPO DRL training model. So these are the training loop that we will keep cycle until we get the optimal result. And here the diagram actually is just want to show the bias and variance trade-off. So this setting we also will set in the model training so that based on this theory between the bias and variance trade-off theory, so that we can estimate the underfitting and also we can prevent the underfitting and also the overfitting of the model. And here are the general hyperparameter for the DQN, PPO, and also the SIC. So the hyperparameter tuning method that we will use for the research is the grid search, random search, and also the cross validation. So here are the evaluation metric that we will use to measure our performance of the DRL model. So we will using the F1 score and also the cumulative return. And after this, we will develop the dashboard for the visualization in order we can do the comparison of the model and also the performance analysis of the 3 DRL model. Our chapter for the initial finding. So for first is initial finding for the data preprocessing and the data cleaning. So first we need to handle the missing data by interpolation. Here is the coding as well the result. So it's have no found of the missing data found after the interpolation. The next we need to remove the outliers. So here are the result that after we remove outliers. And after we clean the data, we have one of the final checking of the data set. And so here we don't have a duplicate or the missing data in the data set. So we already done for our cleaning process. And next, we'll split our data and normalize the data. So here are the result and the coding. And next, we move toward the EDA. So for the first left-hand side here, this is a SP500 close price. And the right side here is the SP500 with the lowering mean 330 and also 100, or we can call it a 30-day average, the moving average, and also the 100 days moving average. So the difference is the 30-day moving average actually is a short-term investment. So the 100-day moving average is a long-term investment. So based on this, actually you guys can see that actually it's quite fit with the SP500 close price. But in towards the 2020 until 2021, it's may you can see here it's not fully fit to the SP500. It's because of a COVID. So next, here is the distribution of the daily return of a SP500. You see the left and the right axis is the same thing, but the difference of a x-axis, the left side is using the percentage. The right side is using the price in the USD. So you see based on the graph that we can know that actually daily, the SP500 they don't have the much changes. Maybe just a 0.001, maybe increase or decrease. It's not have big much different per if we count as per day, as per daily. And next about the correlation heat map. So you can know that this is all the feature that we choose. Actually, they are strong relationship with each other. And next is the volatility point of the market. So actually, this one is just to check the liquidity or the liquidness of the SP500 in the stock market. So you can know that you can see from graph 2016 until 2020, and also the 2021 until 2024. Actually, we can consider it's a standard steady state. But in the 2020 until 2021, we have a high peak here, high different peak here. It's because of the COVID-19. So based on this, we can know that the volatility of the SP500 might be will affect towards the worldwide issue. The next here is a positive and also the negative daily price difference. So actually, we just want to know the today close price. If we compare to the previous day close price, is positive increase or negative decrease? So next. So after I done the coding for the DQN, SSC, and also the PPO model for the trading as an input for the SP500. So here are the preliminary result that I get. So doctor can refer to my appendix and also the coding that I have uploaded inside the GitHub. So based on the graph here, we can know that the SSC actually is outperformed than the PPO and also the DQN because he have a highest network, and also the consistently in the decision making. Okay, you can see that in the DQN, you can see the graph here will be the high peak and the low peak. This one is because even though the DQN it can bring out the high return rate, but the problem is it's less consistently in the decision making. So that you can see the graph will be the dramatically go up and go down. But in the PPO and also the SAC, actually they're quite consistently increasing in the decision making. But the SAC it can earn more than the PPO. It's because of the ability of the SAC. It can handle the dynamic stock market. So the PPO actually towards the dynamic stock market is a less efficiency than the SSC. So based on the Shepherd ratio, we also can know that the SSC has the highest rate if compared to PPO and also the TQN. So after this, we come up with the conclusion. So for the future work, I will create the dashboard development for the performance analysis to visualize and analyze the performance of the 3 DRL model, which is the DQN, SSC, and PPO in my future work, which means in my master project too. And also the policy analysis of the 3 DRL model. So that's all.